Okay, a 0.2386 gram sample contains only sodium chloride and potassium bromide. That's where we messed up in class. It was dissolved in water, and it required this amount of silver nitrate to react with all those halides and make silver chloride solid and silver bromide solid. They want to know what's the weight percent of bromine in the sample. So the weight percent bromine would be the grams of bromine all over the grams of the sample, which is 0.2386 times 100%. So we just got to find out the grams of the bromine. So let's start out by realizing when you're given a volume and a concentration, you know moles. So the total moles of silver is going to equal the moles of silver to make silver chloride and the moles of silver to make silver bromide. Now, realize that the moles of silver chloride is the same as the number of moles of chloride. And that's the same as the number of moles of sodium chloride. Just like to make the moles of silver bromide, the moles of silver bromide is the same as the moles of bromine, which is the same as the moles of potassium bromide. So, because all those are 1 to 1. So to get these, right, this number is not so bad. We'll just take the 0.0484 liters times the 0.04837 molar, and we'll have that one. Now the moles of sodium chloride and moles of potassium bromide, a little more tricky. What we have to realize is that 0.238, that's supposed to be a 2, 0.2386 grams of the sample, right here, this amount, that's the total. That's the grams of what? NaCl and the grams of KBr. Well, what we can do is just say, let's let X be the grams of NaCl, right? Then 0.2386 minus X would be the grams of KBr. Okay, so let's just convert, since X is the grams of, right, since X is the grams of sodium chloride, let's convert this X to moles of sodium chloride, and we'd have that number that goes right there. So it would look like, let's fix that number first. 0.0484 times 0.04837, 2.341 times 10 to the negative 3. So that's just these two multiplied together. So I get done with that. But if I know the grams of sodium chloride, how do you convert grams of sodium chloride to moles of sodium chloride? All right, you have to divide it by the molar mass. So sodium is 22.99 plus 58.44. So whatever my X is, I really just have to multiply it by 1 over 58.44, and I'll have it in moles. So my X is my grams of my sodium chloride. Multiply it by 1 over 58.44, and I'll have my moles of sodium chloride. Do the same now with the potassium bromide. But that grams is 0.2386 minus x. I have to multiply that by the molar mass of potassium bromide. Potassium is 39.098. Bromine is 79.904. About 119. So take the grams of the potassium bromide times its molar mass, molecular weight, and I'll get moles. So that's what this, I get moles of KBr, which is what I want. Okay, so just take grams, divide it by the molar mass, and you'll get moles. So now we just got to simplify for this thing, solve for x. And when we get our x, take 0.2386 minus x, and we'll get the grams of KBr. From that, we need to convert and get the grams of bromine. So that's where we're headed. So I could multiply both sides by might clean it up better. Multiply both sides by 58.44 times 119. Right? Multiply both sides by these. That would still wouldn't. Let's just simplify it mathematically, so I don't lose you. 2.341 times 10 to the negative 3 equals 58.44. 1 over is 0.0171 x plus 9 shift 1 over times 236. I get 2.005 times 10 to the negative 3 minus 8.403. Okay, so all I did is I multiplied through by 1 over 119. Combine my x's. Bring this number over to the other side. Let's do that first. So 2.341 10 to the negative 3 to 2.341 subtract 2.005 10 to the negative 3, about 3.36 times 10 to the negative 4. Okay, that has to be combine my x's, and I get 8.697 times 10 to the negative 3 x. Now I'll solve for my x. About 0.0386. That's my x. Now my x, go back and see what x was. X is the grams of sodium chloride. Okay, I want 0.2386 minus x. So 0. 0.2386 minus x, right? Because that's my grams of KBr. That's going to be equal to about 0.1999, it's pretty much 0.2. Okay, so that's how many grams of KBr I have. So I need to convert the grams of KBr into grams of bromine. So 0.2 grams of KBr, and he said the molar mass of KBr was 119. And I have 1 mole of KBr. I'm going to have 1 mole of bromine, but I need it in grams, not moles. And the molar mass of bromine is 79.9. A mole of bromine, 79.9 grams of bromine. So 0.2 divided by 119 times 79.9. You get about 0.134 grams of bromine. So I can finally do my weight percent. Grams of bromine over the total sample times 100. About 56.3% bromine. So there you go.